Hello everyone, thank you for being here. My name is Milan and I'm the member of textX organization. Today I will speak about tooling and editor support in textX. First of all, I would like to thank my friend Daniel Alero and our professor Igor Dejanovic for working with me on this presentation. So I will start with a short agenda. First, I will introduce textX language by covering some basic concepts and textX CLI. Then I will show you the web playground that we recently created. After that, I will demonstrate the VS Code extension using the language for navigating drone as an example. And finally, I will summarize everything and leave some time for questions. After each section, I will do a short demonstration. So there will be 3 small demos for CLI, Playground, and the VS Code extension. And they will all be based on the same drone example. So let's start with textX. textX is a Python-based meta language for creating domain-specific languages. It is inspired by Xtext, but it is more dynamic and lightweight since it's based on Python. Project is started by Igor Dejanovic in 2014, and now it has 24 collaborators, and the latest version is 4.01. Here you can find links to the GitHub repo, PyPy, and the documentation. So let's explore how it works. First, we use textX to define the grammar of our new language, usually in .tx file with extension .tx. Then textX will build meta model and parser for us. Then parser will parse expressions of our program and generate model on the fly. Model is a graph of Python objects, which are actual instances of Python classes from meta model. Then we can choose that we want to generate some code from that model or we want to write some kind of interpreter. This is the same process, but on more concrete example. Here we have drone.tx grammar file. Program is in the example.dr file. And we can see the corresponding meta model and model in the shape of UML diagrams. And the final output is the executable Python file, which can be run on DJI Tello drone. Now we can take a closer look at each step. So here we see the grammar. It's not very visible, but yeah, we can see the grammar and the corresponding meta model. I will not go into details about rules and syntax of textX, but it is quite self-explanatory. We can see that our program should begin with begin and end keywords, and in between we have a set of commands. We have 3 types of commands: move, rotate, and flip, and they expect from us to specify direction and the number of centimeters or degrees. And we can see the same thing in the meta model. We have 3 classes, each corresponding to 1 type of command. Second step is the model. Here we have 5 specific commands, and in the program, and model has 5 Python objects, each one corresponding to the 1 command. And here is the final output. It is a drone.py file. And on the left, you can see the Jinja templates that we use to generate this file. This is how it would look in the Python code. So after installing textX, it provides us 2 ways of loading meta models and models by providing string or the path to the file containing the grammar or the program. So here we are using the reading from the file. After loading meta model, we can call model validation based on that meta model. If there is an error in the grammar or the program, the code will break. We can do the same thing with the textX CLI. We have a check command. We can use it for meta model or model validation. In case of model validation, we need to provide the grammar which we want to consider when we are validating the model. And if the language is registered, I will get to registration later, then we don't need to specify the grammar. We can specify language by the name, or it can be implied from the extension of the file. Here are a few more commands for listing registered languages, listing registered generators, and the command for generating code. Here, it expects from us to provide the name of the language and the target. That's because when we create the generator, we need also to specify the target, because for one language we can have multiple generators. For example, we want to generate code in Java and Python from the same model. And finally, we have commands for visualization. They actually use the generate command, but they're called on built-in generators, which are built in textX. We can choose between dot and plant.uml format. Second command in each example is for actually getting the viewable PNG file. Now I'll do a short demo of this. So here you can see I will provide a link to the repo with 3 demos. I will open the first one for the CLI. I hope you can see. Okay. Each example has a README file, so you can follow the instructions. So first we create the virtual environment and activate it. That's already done here. And for the VS Code, we need to select that specific Python interpreter. Then we do installation of textX. The only dependency here is Arpeggio library, which is a parser created by Igor Dejanovic. And then we can do validation of model and meta model. So this is the example I showed on the slide. So if I try to, for example, make some error in the grammar, I will get the description of the error and the line where it happened. Same thing with the actual program. Now grammar is valid, but program is not. It expects rotate command on the line 3. And yeah, here we have commands for listing languages. textX is there by default. We can do validation from the CLI. As you can see, everything went well because they are valid. We can register generators. And here you can see the 3 default generators here. Now let's call the generate command. Now we got the drone.pu file, and now we can use plant.uml to get the actual PNG. We can do the same for this. And now we have a model of our program in the dot format. So as you can see, in order to try textX, we need to have a, I will get to the web playground now. We need to have Python and pip installed. We also need, usually we will create some virtual environment where we install textX. And then we need, every time we want to test something, we need to run Python script or CLI command every time we want to test something. It would be nice if there is some online link where someone can just go and start experimenting with the language right away. So then we decided to create the web playground. There were some challenges and considerations about the language client and the server, about their architecture and the way of communication. So language client was pretty straightforward. It should be inside the browser. But for the server, we first thought it will be on some remote server, and we will have a HTTP communication between them. So we will have some REST API, stateless requests, but then we need a way to manage sessions and to store states of documents and connect it somehow to the active user. After that, we thought, okay, maybe it is better to have, for each new user, active user, we will spin up a new process, and the communication, we will keep live communication between them, and they will exchange messages via WebSockets. But language server protocol is not designed for this way of communication. It would be better if both language client and the server are on the same machine. So we started considering that. And then we saw two options. One is to download language server on the user's machine, run it on some port, and then establish connection. That seemed a bit an overhead. And then we wanted to see, is it possible to run language server inside the browser? The problem here was that textX is based on Python, and also language server for it will be in Python. So I created this project this year, Web Playground. So Lifesaver here was the library Pyodid. It's a Python distribution for a browser and node environment. It is based on WebAssembly, and that enabled us to run the text to language server inside the browser. So we decided to run it inside the web worker, so we don't, for the sake of the performance, so we don't block the main UI thread. Language server is based on the PyGlass, which is a library for writing language servers in Python. For the editor, we use the Monaco editor component from Microsoft, and language client is based on Monaco language client library by TypeFox, and VS Code language client from Microsoft. Here you can find links to the repository and the deployed playground. This is how it, it's not very visible. This is how it looks. So we have a grammar and one editor for grammar, one for program. We have links to documentation, GitHub. There is also the way to change the theme, toggling for the theme. We can do visualization of both meta model and the model by clicking the right icon at the top of each editor. There is a status bar at the bottom showing the current state of both editors, if the grammar, for example, is valid or not. And yeah, the most important thing is the set of examples in the drop-down in the header, because when you learn something, it's good to follow some example. So now users can preload multiple examples. And there is a share option, which takes content of both grammar and model editor, embeds into the link, and in that way you can share ideas with a colleague or professor. So yeah, these are the features I mentioned. Yeah, we also have a basic syntax highlighting, and this is the link to the drawn example. So we don't have drawn listed here, but the content is inside the URL. We can see if we make some error in the grammar, it will be reported on the line and in the status bar. When we fix it, we should see the green icon here and the message that it is valid. Same states for program. We can do same thing I showed by running generate commands with CLI. We can do visualization, preload examples. Now we get a warning that the content you have currently will be lost. We have some simple examples and some more complicated, like this one, for example, with a long grammar. Yeah, change themes, sharing, and yeah, I think that's basically it. Now I'll get back to the presentation. So Web Playground is great for prototyping or learning about textX, but if you want to do serious development, for example, you want to have projects with multiple languages or one language defined in with grammar defined in multiple files, or you want to use code generation, then VS Code extension is the way to go. This is a project created by Daniel Alero in 2018, and it actually contains from two parts: textX language server, which is based on PyGlass, project also initiated by Daniel, and VS Code, actual VS Code extensions. Here are the links to the repo, PyPy, and the marketplace, VS Code marketplace links for the extension. So after installing it, there will be a new option in the sidebar with X icon, and there will be two sections. One is listing the projects with the registered languages, and the bottom one lists all the generators. It is also possible to install the project by providing a VL file by clicking on the green button at the top. And there is one more way of creating the project. That is by clicking the right button and going into the context menu of the setup.py file, which is the configuration file of the Python package. And there will be an option to install or uninstall the project. That installation will actually create a new Python package, which will be installed inside the internal virtual environment of the extension. So here you can see a small screenshot of the newly installed package and the two packages which are actually modules of the textX language server. Yeah, with VS Code extension, you also get the grammar and program instant validation with error reporting and more advanced syntax highlighting. I will show VS Code extension on the drawn example. I just want to show first the structure of the project. So here you can see the program and the grammar file. There is also project configuration file in setup.py. And one more important file is init.py inside txdrawn folder. It contains language and grammar definitions. And there is also a Jinja template for generating code. Here is the link also to all the demos. Yeah, this slide explains the registration, but I will do it in the demo because light team, it's better to see. Code demo, VS Code. Here you can also follow the README file. So here is the setup.py. When I do right click, there is install option. And here in the textX sidebar, you can see the textdrawn language. And yeah, this is a project, and it can have nested. We have, in this example, only one language in this project, but there could be multiple languages. And yeah, we have this custom generator, drawn Python. Setup.py. Okay. In setup.py, in entry points of the setup function, we have two entry points, textX languages and textX generators. And they reference the functions from the init file inside the textdrawn. These functions are annotated with the decorator. For language, it expects name of the language and the extension. This comment will be actually description of the language. And for generator, also expects the name of the language and the target. This example also uses the textX Jinja generator, which is a helper library if you want to generate, for example, template-based generating. You can provide the root file of your templates, and it will go recursively and generate all templates it found. So let's get back here. Yeah, we can see the error reporting, also on grammar. And now if we want to run this has a room for improvement. So if you want to run the generator, at this moment we don't have option to do it from the view. We need to go inside the virtual environment of the library, and then we can run. This is one thing that we plan to improve later. So here in this folder, you can see drone.py file. And I would like to execute, to run it on the drone, but I couldn't bring the drone here for the safety reasons. Yeah, that's why I made a short video as a demonstration. So here you have, as a reminder, the program with the generated code, and here on the video I also run generate command. Yeah, there is the file, and now I will execute that file on the drone, and you can follow the movement. So it will first go left half a meter, then it will rotate 90 degrees, go back up 20 centimeters, and it will finally land. So to summarize everything, so yeah, these are the latest updates we have in textX organization. So we created this web playground. Language server project is upgraded, Python, textX, all dependencies, and now we have two new versions of new version of two modules, LS core and LS server are on 0.20, and also VS Code extension is on that same version. Yeah, we want to, these are some plans for future. We want to add a project scaffolding option inside the VS Code plugin, so you can easily click one button, maybe provide name and few more parameters, and it will generate the skeleton of the project. Maybe it could be the small to-do language or something, and then you can start developing from that point. We would also like to add run code generator option from the tree view, and we are also considering, but it's still consideration, so to apply the same approach from the web playground to the extension. Instead of installing language server on the user machine, we were thinking to actually use the nodes, VS Code's node environment, and run language server inside the PyODID from there. But that's still consideration. And for playground, we want to replace custom PyGlass implementation of the language server with the now functional textX language server library. Yeah, this was all from me. Thank you for the attention. Thank you. And now it's time for questions, if there are any. Is it at 25?
Are there any questions? For the downloading the language server into the web browser, what size do you have there? What's the download?
To download language server inside the browser.
Do you run the web server, language server as WASM, right?
Yeah, yeah.
Yeah. So I guess you need to download it when you.
No, we have a code in the web worker, which actually pulls the PyODID, and then with PyODID we can run pip install, like micro pip commands for installing additional packages. And then we install the PyGlass, and we have some custom implementation there. So it can run Python code, but also install some additional libraries that we need.
Yeah, and so if I've never visited the playground and now do this, and then all of this happens. How much I'm downloading?
It is few seconds. Actually, yeah, I don't know what, but it's quite fast. You can see at the bottom. Is it? Well, let me just. You see, starting textX language server. So it's still not active, but it's like a few seconds. I didn't measure the size of the package. You're welcome.
Sorry. Yeah, it's pretty impressive, I think. But, so, might just loaded if at 2.5 megabytes.
That's compressed, 9 uncompressed.
Compressed, maybe PyOD have a like minified version.
Yeah, I guess so. The largest thing I see is 2.5 megabytes compressed and 9.
That's not
9.
big. Great.
I'm pretty impressive for downloading all of it.
Yeah. Thank you.
Next question.
All clear. There's no any AI stuff and nothing complicated here.
Is this used mainly for teaching, or also aware of it used in some industrial context?
Currently, it's used for. I know it's used for teaching, like for master thesis for some students. But also, I know for one company that use it in as an industrial. But professor, maybe you can answer this.
It's used concretely a web environment. This playground is still not used in teaching because it's fresh. But I guess we will use it in this semester because it's very useful to students. Not deal with the installation of the process, so just play around. And textX is pretty old, so it's used in commercial settings and in academic environments. So the library itself is very small. The download is small because everything without much dependencies. You don't have to do much dependencies.
So when can we expect the line web?
Well, I think very soon because you have intriguing with the line web on this presentation. So.
Yes, thanks for your talk. How did you realize the language grammar, the grammar language for the textX itself? With textX, with something different?
Yeah, textX can define grammar for itself. It's defined in the textX.
Are there any more questions? All right. Then thanks a lot.
Thank you once again, and thank you for the questions.